Okay, so welcome to the first in trolling physics with the Wafi. So, I've got a meme for you to have a look at here. Here we have two of the characters from My Little Pony. And they're in a race, and we've got worried about losing the running of the leaves, get a metal hat, affix a magnet, and hey presto, infinite propulsion. Problem, Applejack? And you can see the perplexed look on Applejack's face there. Yeah, I do know the characters' names because my children are obsessed by My Little Pony. So, what's the problem here? Well, there's actually probably two things going wrong here, right? Firstly, whenever you see the word infinite, you're always kind of going to have a problem with that because infinite propulsion kind of implies infinite energy as well. And energy cannot be created or destroyed. So where would you be getting all this energy from? That's one issue. And I think the main issue with this really comes down to Newton's three laws of motion. So let's have a quick look at what Newton's three laws of motion are. So really, I think we can talk about this just by looking at number 2 and number 1. Number 2 is that basically, if you want something to accelerate or speed up, you need to apply an unbalanced force to it. Okay. So if you have, let's say, a roller skater. Here we are. They're on roller skates. Not the best drawing in the world. In order to make them accelerate, they need to have an unbalanced force acting upon them. Okay? The larger the unbalanced force, that's what this is going on to say, the larger the unbalanced force, and the mass as well, they both kind of combine together to give you what the acceleration is going to be. In fact, they combine together. All of this is really just saying the equation F equals ma, which basically, if you wanted to know what the acceleration was, you could rearrange it for A, which gives you F over m. And it's basically saying make the mass bigger, the acceleration gets smaller. Make the force bigger, the acceleration gets bigger. That's what it's saying. Okay, so that's going on, right? We've got the person, they've got a particular mass. This is person A, let's say. But in order for them to be accelerated, you've got to apply this unbalanced force to them. So how are we going to apply that unbalanced force to them? Well, let's start off with a sort of simpler example. Let's say we have person B. Let's do person B in a different colour, shall we? Person B, okay? Person B also on roller skates, so we can sort of expand on some of these points. Person B, let's say they give person A a big shove, push, right? If they push person A, we can think of it as the force acting on person A is from person B, but it's impossible for person B not to be pushed backwards, right? So we can say that when person B applied a force to person A, person A also applied a force to person B. Confusing, isn't it? So this is how it's stated in the third law. For every action, there is an equal and opposite reaction on an opposite body, actually, right? So there's an opposite reaction, which is there was this action, and this is the opposite reaction. They're equal in magnitude and opposite in direction. So you can't get away from that, right? And that comes up in all kinds of places. So you might think, for instance, hold on, if I'm walking along on the earth, right? That's me walking along, and in order to sort of start from rest and move forwards, a force would need to act on me in this direction. So what's the opposing force? Well, if you think about scraping your feet along the floor, your feet are really just pushing the earth this way, right? So as you accelerate in this direction, the earth actually is going to accelerate a little bit in this direction. The reason why it's not very noticeable, the acceleration of the earth, is because if we use the second law rearranged for acceleration, it's F over m, and the mass of the earth is massive. So the acceleration of the earth is going to be tiny. Whereas for you, again, the force is the same, equal and opposite in direction. I suppose I could put a negative sign there to show that. But your mass compared to the earth is absolutely tiny, so your acceleration will be larger. Right, another nice example of the third law that's worth talking about as well, which people always seem to have problems with, is let's think of an object falling. An object falling has gravity acting down on it, okay? Right, let's just make this object falling blue, so let's stick with a similar colour scheme. Right, the object falling has a force acting on it, right? So the earth is pulling it down, but believe it or not, the opposite and opposing force is the object pulls the earth up as well. right, with an equal sized force in an opposite direction. So again, we have two accelerating bodies here because two objects, because there's two forces acting on two separate objects. So let's take this back now to Rainbow Dash's idea. Okay, so Rainbow Dash thinks she's going to get pulled forward by the magnet, right? But Rainbow Dash is also going to be pulling the magnet towards her, right? Now, these things, all that's actually going to happen is that this bit of metal is going to maybe bend if it's a really strong magnet, or that's it. There's no external force acting on Rainbow Dash to accelerate her forwards. So she would stay stationary, or she'd continue doing what she was always doing, which is just an expression of the first law: an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and same direction unless acted on by an unbalanced force. Okay, so I hope you've found this little trolling physics fun. Got loads of other cool little pictures and stuff. If you've got any suggestions, please send them to me. Thanks for watching. Comment, like, subscribe and share, and click the bell button to get notifications.